thanks everyone for coming. My name is Mateusz Sadowski, and today I will tell you a little bit about open source robotics. But first, before we start, who of you has some experience with robotics? Raise your hand, please. Wow, plenty of experience. That's great. So, use this one. Okay. So, closer. Okay. Thank you. So first, let me tell you how I got here. The backstory is I was really into dead set on getting into IT when I was about 16, 17. But I had a very good teacher who introduced me to databases. And this was me learning SQL at 18 years old. And I said, no way, I'm not gonna do that. Instead, I learned that if I learn mechatronics, I can repair washing machines, which is great, new dream. And I decided, yeah, let's go this direction. So at least I will have some useful skills in life. So one thing led to another. Started doing some university projects, went into drones for some reason, helped build some autopilots, then started working in different places, making distance sensors for UAVs as well. I was playing around a fair bit. So in this slide, you can see a simulation of a drone that was controlled by a haptic device. In this one, you can see a 3D mapping payload where I integrated a GPS, IMU, and a LiDAR, and I could just walk around, scan things, and yeah, it was just a little bit small proof of concept. Then I was fed up with work. I decided I would go my own way. I started consulting, helped build these robots, which are huge mobile robots from a company in the UK. Did some more consulting with some autonomous boats. Then I went with some company building these heavy metal devices for liquid aluminum analysis. And one thing I learned there is if you work with liquid metal, you should make sure the robot doesn't pour it on its own cables. Otherwise, things stop work. And in 2018, I started a project that I think got me here. I'm not sure who reviewed my proposal, but it's Weekly Robotics. It's a newsletter that I continue to make. Every week, I share some interesting news and projects in robotics. Feel free to subscribe if you like this kind of news. Currently, I work as a dev relations at Foxglove. We build these visualization tools for robotics, so to visualize multimodal data in real time. And yes, I fixed a washing machine. The drain filter was clogged. This is not my picture, it's from the internet, but more or less that's how it can look like. And your socks might be there as well, if you're wondering. And this is an opinionated talk, so I'll be sharing some thoughts where I would recommend you to go. And also this, because it's opinionated, it allows me to say some things. So one thing I can say is I would not recommend to use Windows for robotics development. And also I have to apologize, I lied. In the description, I described quite some many projects that I would cover. But when I started working on this presentation, I realized like this would be the most boring presentation ever. It would look more or less like this. So if you are interested, feel free, like this is a list where you will find these projects. I also uploaded my slides so you can download it and see all the hyperlinks. So yeah, not gonna do that today, sorry. Instead, we'll talk about robots. So I will talk specifically about robots, so things that move, And by the way, I believe, and it's an opinionated talk, so I can say that washing machines are robots. No offense to any robotics people here. But before we start, we need to talk about middleware. It's quite an important concept in modern robotics, at least in my opinion. And it's all about having different nodes or execution modules that talk to one another. And we have a couple of options right now that are open source. First one is Robot Operating System. Who here has an experience with ROS, good or bad? Wow, plenty of people. Nice. I would say ROS is quite mature. The learning curve is quite steep. From my experience, if someone didn't work on distributed system, it takes them about 3 months to get comfortable. But the community is huge, and we have thousands of packages. Copper is quite new. It's Rust-based. It has zero copy abstractions, but because it's new, you will probably need to contribute to it if you want to make it work for your project. LeRobot is not a middleware. It's also relatively new, but it's about end-to-end robot learning, and it will get you to a moving robot real fast. So that's why I put it here. And last but not least, you are here. You know how to manipulate the data, so you can roll your own thing. And a shameful plug, we have at Foxglove an SDK, which allows you to visualize your data very easily. So if you do that, yeah, check it out. It's 5 lines. You can just send some messages and visualize. And then we have some simulators. So you don't always want to pay for hardware, so you can play around. And one of them is Gazebo. It integrates with ROS quite well, but it's quite rough around the edges compared to the previous version of Gazebo that is now end of life. We have Isaac Sim from NVIDIA. The problem with this is you need to sell your kidney probably to get a GPU that can handle that. But it's photorealistic, and it also plays quite nicely with Robot Operating System. By the way, I forgot to mention, Robot Operating System is not an operating system. Then we have Mujoko. It's more for research and is a physics simulator with C and C++ bindings. And Kimberly, who's here and gave a very good presentation this morning, has a list of over 160 robot simulators. So if you didn't find something interesting here, check it out. Now, a bit of a methodology. We'll consider 3 categories: cost, complexity, and sim readiness. So for cost, you will see that the list is organized by price. We assume that 3D printing and filament is free. And your time is free too, because we are having fun, so who would worry about this? Then complexity. Scale 1 is a weekend project, and 5, it will probably take a couple of months to do that. And sim readiness, like I will mention some tips on which simulators you could use to run this. So let's find you a project. So first of all, we start from space. There is a project called INTBall2 from Japan Aerospace Agency. It's a ball that runs in space, and it will be free if you run it in simulation. If you want to run it in real environment, you'll probably spend millions of dollars. One issue with that, the software is quite old and it's end of life. So you need to balance your willingness to be in space versus learning stale technology. Then we have Astrobee, which is a similar robot also in ISS, moves by blowing air through some nozzles. And yeah, you can navigate. You can also simulate it. Also quite expensive to get to orbit, so be careful. And it runs ROS, and it can also run some side applications in Android. Then quite more realistic robots that you can build. We have OpenBot. It's about $50 in parts. It uses Arduino or microbit for driving, and all the brains runs on your phone. So assuming you have a mobile phone, Android mobile phone in your drawer somewhere, which most of us probably do, it will be $50. And there's no simulator for it. Then we have Pedro, which is very small robotic arm, also Arduino based. It's about over $200 to build because the PCB is quite pricey. But if you are here, you can probably control servos by yourself if you're very motivated. So it can be about probably less than $50. And also there's no simulator for this one. Now we have SOARM 100. It's a setup where you have two robot arms, one for teaching, second one for execution of your tasks. This one is a Le Robot flag project. It's about $270 for both arms, and it will get you moving quite fast. Out of the box, it has Mujoko simulation, but people are very interested in that project, so some people already integrated it into Isaac Sim and Gazebo. And this was me playing around with this arm, visualizing it in Foxglove. It was probably 200-line Python file to move it around with LeRobot API and record the positions and then replay it. So it's quite neat if you want to get started very quickly. Reachy Mini. So unfortunately, this is coming soon, not yet available, but it costs about $300 fully assembled. And half of my friends bought it from their learning budget. So just giving an idea here. And by the way, I'm not affiliated with Poland Robotics in any way, but you will see them quite a bit on this project. Now, who has seen these guys in action? Oh, not many people. Subscribe to the newsletter, you'll see this. So if you see these robots and if you say best I can do is about 432 euros, you can build this one. It's called OpenDAC Mini. It runs on a Raspberry Pi Zero, and it's very good for reinforcement learning. And yeah, it's quite nice. Lots of 3D printing though, so be prepared to spend some time in the lab. Then we have Lekivi. It's also affiliated with LeRobot, and it uses Raspberry Pi as a compute. It is this LeRobot arm on a moving base. It's also quite simple to build, so yeah, you can do that. Now, from the guys that built this robot, they are called K-Scale Labs. They also created a smaller one that costs about $850 in parts, last I checked. So in their website, you will see that it should be about $350, but I don't think it's possible to buy these servos. And almost all this price is just servos. And it supports Isaac Gym as well. Now, this is a very cool project. It's called JPL Rover. It runs ROS2. It has 10 motors. It's quite fast. It has nice suspensions for space rover. And it's quite complex to build. The developer says it's about 160 hours for experienced people. And it has also a Gazebo simulator, so it should be quite fun. Now, since we are over $1,500 threshold, Do you know what this is? Yes, that's washing machine. So it should be here because it's a robot, obviously. But apparently there are no open source washing machines right now. There's some dead project, but if you guys look for some side projects, please. Now we have Berkeley humanoid light. This one, you can see it's a bit more complex than the previous robots. It's about $4,000 in price. They estimate $200 or filament, but we assume it's free, so it's cheaper. And yeah, it will be quite complex as well. And also, I haven't seen this robot standing upwards, so you might need to do some coding. Now, an observation skill test. Who noticed this gear icon in some of the slides? Raise your hand, please. Okay, we have a couple of people. Now, all the projects with this icon, they use the same servos. So you can reuse quite a bit. They are, well, both of them are almost the same because you have the same arm on a different platform, but also this OpenDAC uses them. So if you go this direction, you can consider that that fact, and maybe you will rebuild into something else. Now the final boss of this presentation, it's called Reachy 2. It's the most expensive humanoid robot I could find that's open source with a small asterisk. On the website that says it is fully open source, but last I checked, the CAD files were not there just yet. But yeah, I think the company is working on that. So hopefully we will see all the files and you can build this. If you want to buy the most featureful version, it will be $70,000 right now. It runs ROS 2 under the hood. It supports Dora, which is another middleware that we didn't cover here. And some people are working on Lerobo integration. And they also have some support for Blender as well, which is quite interesting because you can animate some things. And this is the project that I choose to go deeper on and cover architecture a little bit. So you'll find some specs sheet on their website. The robot, actually, you can move it up or down because it's just the torso. It has a quite complex arm with 7 degrees of freedom. And there's a mobile base that's omnidirectional. And for perceptions, there are a bunch of cameras, time-of-flight modules, depth cameras, IMUs as well, I think, but in the mobile base. And also the mobile base has a 2D LiDAR that scans the distances in one plane. The base looks like this. It has 3 VESCs, which are electronic speed controllers. 3 wheels, omnidirectional, so you can move in any direction, like X and Y, straight. And also, as I mentioned, it has a LiDAR. This is a very simplified diagram. I had to chop lots of things from it just to make it presentable in a short amount of time. So this is the base. In ROS 2, you have a driver for it, and it connects to the rest of your stack. I think the most interesting part of this robot is Orbita. This is this head mechanism that you see here. This is how it looks on a CAD model. You have 3 disks, and each disk rotates own arm. And by rotating the disks, you can move all the arms and change the orientation of whatever is attached to these arms. I think it's a very clever mechanism, and it could be a good weekend project, or maybe 2 weekends, just to play around with this idea. It uses these orbitas in the arms, so you have 3 of them, and 1 in the neck. And the joints control is there is a low-level controller written in Rust that, according to the specification, runs at 500 hertz. But when I looked at the code, because it's open source, I think it might be 1000 hertz. So please double check this if you are building this. And the high-level control is through ROS2 control framework. And we have also a bunch of nodes for the perception. And if you want to program it without all the overhead of ROS, they have an SDK server. So you can run some Python scripts and command the robot. How are we on time? Do we have a time for a demo? Let me just check. Yeah, we have time. So let me run this. Sorry, I'll need 2 hands for this. 1 second. Okay, you actually need 2 hands with Tmax usually, but I'll try. So what I'm doing here is I'm running Docker instance provided by Poland Robotics. So you just run this and you have a full robot running in simulation, kind of. It's not a proper physics simulation, just showing the fixed joint positions. Just because I didn't want to melt my computer here. So this is running right now. Oh yes, thank you. So, all right, thank you. So in this one, I'm gonna run Foxglove, which is the visualization stuff that I work on actively. Sorry, it's in the wrong screen. So I can connect to the robot right now. And you can see the visualized state of the robot. Most of this is thanks to ROS. Out of the box, I can visualize the state. I can drive this around. It's set up right now so I can rotate with these arrows and then go forward and backwards. So quite simple. And now the magic of the Python SDK, they actually have an emotions module. You can run emotions on the robot and it will just move automatically. They have some pre-recorded emotions, I think about 20 or so. And the robot will just do whatever it's ordered by the code. And what I'm showing here, just as an example, is the commands to the left arm position controller. So this would give you some ideas like what motions were recorded, and you visualize the robot. The beauty of ROS2, I think, of the architecture that comes with ROS2 is that it would work the same way on the real robot, assuming like the physics are good for you and you didn't make any mistakes. So yeah, that's it from me. At some point it will dance Macarena, but since we have how many? We have 15. Okay. So I can grab any questions right now. Yeah, please.
Let me give you an example. No.
Okay. Does this still work? No.
Yeah. Hey, thanks. Thanks for the talk. The slide mentioned that Reachy 2 was 70,000 euros, right? Do you know why? Like, what components are in there that are just so like an order of magnitude or a couple of orders of magnitude more expensive than the other robots?
Right. Does this work or not?
Yes.
Yeah. Okay.
Be closer.
Yeah, it's good. Yeah. So one of the reasons this is not very apples to apples comparison on the price is because the price of the Reachy you see is the price you pay to the company. So there is markup, of course, because they sell this robot as well. So it's open source, but they sell it, and they need to earn money. So they will probably, add something on top. But also, when you have this orbita mechanism and so on, I imagine these are quite pricey to manufacture. But like I cannot tell you the breakdown. Like there is no BOM list right now. Hopefully we will get one soon, and then you would know exactly how much it would cost. But I would say it's probably manufacturing custom parts that's right now most of the price.
Okay, thanks.
Anyone else have any questions? All right, here we go. Can you have the glasses, please? Thanks. Yeah, so my background is also mechatronics, so that's why I think we have quite a similar view on washing machines. I would also say it's a robot. So does that mean for you that now we should program all our washing machines and every kind of mechatronical system with ROS?
I wouldn't do that. Like I there's this view in robotics, and this is opinionated talk, so I can say that as well. Is that when you have humanoid robots, I think these robots have too many degrees of freedom for most of the tasks that are now proposed. And I think it's the same case for washing machines. Like don't overcomplicate it. Make it as simple as possible, and yeah, don't make your life too difficult.
Anyone else have any questions?
Okay, then we have a coffee break. Sorry.